Hello everyone, welcome back to my YouTube channel. My name is Ariel Kusaev. Today we're going to do some interesting analysis on LockBit 3. So LockBit 3, it's another version of the infamous LockBit ransomware, where you had version 1 and 2. Now there is a version 3 named LockBit Black. It has some code reusability. Basically, it uses code from other ransomware like DarkSide and Black Matter, from what I heard. And basically, here is a publication of VX Underground. They posted about this LockBit and the samples, basically. And yeah, we can go straight ahead into the Malware Bazaar, download it, and start our analysis. Basically, before we do the analysis, there is basically GitHub repo with a PDF of a already analyzed sample, basically the same sample. And we can see here, it uses an interesting mechanism. Basically, it uses a password in order to decrypt itself. So it basically uses an RC4 KSA password, and this basically encryption key or password will be used in order to decrypt the first stage, or the first stage of the unpacking. Basically, there are basically a number of layers to the packing itself. It starts with some XORs and then RC4, and eventually it go and resolve APIs, Windows APIs, functions, and basically there will execute. Now, all this is from what I heard, because from what I understood, they are using DarkSide and Black Matter ransomware code. So basically, they're doing the same with the dynamic API resolve. While the ransomware is executed on runtime, will go and resolve the APIs. So we have to use this key in order to start our analysis. So we'll go to Malware Bazaar, download the sample. You download here. If you go back, you can see basically we have the password here. So thank you, VX Underground, for posting it here, so we can easily copy and paste it. So basically, let's go put it inside our virtual machine. Disable NAT. I think I already disabled it, so we don't have internet connection. Okay, it's not connected. Amazing. So let's do extracted. Call it EX. So it will not be executed like this, and call it LockBit Black. And basically, let's do an initial analysis. Let's use detected easy. Open it and determine whether it's packed or not. Of course, we will see again from what I heard already. So yeah, we see the text section is packed. So we'll basically, in this section we will see a lot of gibberish. I believe that this section will be unpacked after a while. Maybe the iText holding the actual unpacking stub or decryption mechanism. Over the data section, which is also packed, and kind of interesting. So if we have a value which is higher than 7 in its entropy, it's an indication that it's packed. As you can see, you don't have any information what kind of language it's compiled, C, C++, .NET, C#, whatever. Let's try to use CFF Explorer. See, maybe, yeah, no information. It's maybe stripped or whatever. So yeah, basically, other indication which I can try to determine. Let's use pbir. Determine the import address table, basically the number of functions, the imported DLLs. If I go here to imports, okay, yeah, so not surprising. Malware, which are basically packed, they have a very small DLL imports, and in each DLL import they have very small number of functions. So if I go to kernel 32 DLL, I can see here load library X, which will be used to maybe load some external DLLs. I have here get proc address and get module handle, which will be used as basically for the dynamic API resolve, I believe. So load library to load the DLL, get proc address to get a specific function from the loaded DLL, and also the both of the functions get proc address and get module handle are basically used, most likely will be used for dynamic API resolve, maybe with some hash function or something like this. This we will discover for ourselves. I think that using tools like Unpack, which HasherZ wrote, amazing tool, will not help here because we have this RC4 password. It will help in other cases like, packers like pcompact, SPAC, which are basically, they do some compression algorithm without using any key or stuff like this. But in this case, because we have a key, tools like Unpack or Unpack Me website will not help you here, which both of them are amazing tools, by the way. So let's load this file into IDA and start our analysis. So go to desktop, let's do all files, LockBit back. And let's do load resources. I don't think I have something to check in the resource section specifically in this case, but let's validate resource hacker. Yeah, nothing. Okay, so let's go, and first of all, I want to check entry points. I have only one, so this entry point, yeah, as I thought, the iText is basically the unpacking stub. So again, if I do detect it easy, see basically the sections again, you can see that the iText is basically not packed, and it's basically uh, it holds the unpacking stub itself. Of course, the section or the memory region that the unpacking stub resides cannot be packed or encrypted, because you need to have some clean code which can encrypt, decompress, or deobfuscate the packed, encrypted, or obfuscated code, basically. Okay, so this is the point. Basically, if I go to imports, I see a very small amount of imports, exports nothing, because it's not basically it's not DLL or this kind of thing. If I'll do shift F12, basically will not see, strings or something like this. Everything is gibberish, basically. I have only the imported functions here, mentioned as a string, nothing else. Yeah, basically, let's continue here. So as I said, we have here one entry point, the public start. Let me try to maybe make it a function, but yeah, I can try to undefine it, maybe reanalyze the code using the C keystroke. And start again. So again, reanalyze key for function. Yeah, nothing really. So it will not give me this option. Doesn't really matter. So it will. So the code here starts with to no operation, which basically does nothing. And there are a bunch of functions. Try to go to the end. See, really looks like unused functions or whatever, or like assembly instructions. Looks like gibberish or encrypted. Yeah, interesting. 3, debugger. Okay. Oh, see here. All paste. See, looks like, you know, kind of shell code, or I don't know. Okay. Oh, okay. Okay. Here, and there's a bunch of code here. Okay, so um, the thing basically I choose to like start from the end because out of times in unpacking you'll go to the end of the of the code, or somewhere you will search for indirect jumps or calls or something which will tell you that there is maybe a loop or something like this. So don't see here something specifically. Let's try for the first function. So if I go to the first function, yeah, it seems like a legit bunch of code. There is a loop here, decrementation, call some functions. Okay, so here again, nothing really. So I think we need to like focus on this function. We'll go here, do some like initialization, loads a value in this variable to EBX, moves this variable, does loop, whatever, does a call. Okay. And I see here something with fs something. Most of the time, if I see fs something, fs30 or gs60, it will refer to the PEB, process environment block. Maybe it will use to, I don't know, resolve the functions or do some dynamic API resolve. I don't know. Okay, so this is it. Basically, if I want to check whether this function will be called once or even more. Okay, something going on here. So yeah. Okay. So let's get down to business. Let's put here a breakpoint, debugger, process options, and I'll put this pass this one. This is the password basically. Okay, so this is the same password that I saw in the Bazaar loader, Bazaar, the Malware Bazaar website. Basically, the same PDF that we saw from the incident response of this guy who already did some research on the malware, and basically this is the RC4 encryption key, which will be what we'll see will be used as a decryption key for some code section here. So let's do OK. And yeah, let's execute. Hope it will not encrypt my computer or something. Okay, so it got to the breakpoint. Close the windows here. Make it this. Okay, so let's go. It moves to EBX. This value, what do we have here? Try to resolve it. It has the value of 1 basically. Moves this value to ECX for whatever reason. I think it's part of the loop. Yeah, used for a loop. I don't know why it's used here. So let's just get over with it and go to this function. So okay, so this function will go inside here also, goes to ACX. So basically it's FS30. It will give us the PEB basically, as we can see here. So and name it peb here. Okay, so basically let's return from it. Then it will go to the basically go and take piercing users. Let's do just synchronize X view, and again go here to EAX, which basically the value here is moved. So EAX. So basically I can see here the C users. Okay, so basically it loads like the environment variables, and as you can see here, you can see the pass and the password itself. So basically it loads the environment variable or the command line argument. So if I go here to process hacker and do LockBit black, basically as I can see here, this is basically the command line. So basically it goes and parses the command line argument from the peb structure. Basically each process in the system has the user mode data structure, which is called peb, process environment block. It holds interesting information. I'll go real quick, peb msdn. Basically it holds values like if it's whether it's being debugged. For example, if you see a malware which implements the function of is debugger present, it literally goes into the peb structure and checks whether it's the value is 1 or not being debugged. If you go to if basically you go to peb ldr data here, it will go, and from here you can basically enumerate DLL and loaded modules. So this can be potentially used for loading dynamically loading of DLL of functions from DLLs, used for dynamic API resolve, and basically as you can see here from this, it's basically a linked list, flink, blink. It's a and each one of the functions of the DLL function will be presented in this peb structure. Okay, so basically in this case it will just go for the command line argument. Basically it will take it from the peb as we basically can see here from the command line argument. Okay, so the return. So here we understood basically it takes command line argue here. Okay, so then it calls this function for whatever reason. I don't know what it is. Like to not waste too much time. Check some values. I don't know. I don't know. Okay, let's go with the flow. So check the return value is 1. And okay, so basically it goes here. So it will do a check if it's false, or basically if it's true, it will go and exit the program, I think. So basically it will go out and see we have goes to this block thing. From here it will do its unpacking or whatever. So loads data from here. So we have basically here push EAX, which is 0, and whatever try to understand what actually takes here. Okay, so let's, you know what, takes argument 0, argument 1, Okay, now it's not initialized or whatever. Okay, let's go inside. We see here, move to ESI, move to EDI. So in ESI, we have, oh, I think what it is. Okay, DB6602. Ah, okay, so ESI holds basically the password, the decryption key basically. So this is the decryption key, the argument taken from the password. Yeah, so this is the um this is the pass or pass key. Okay, so this is the pass key and the argument. And what is the zero argument? EDI. Yeah, I think there was something with the destination or whatever. Maybe destination buffer. There's some source. There is a XOR here. So let's check what it XORs. Nothing. Okay. Okay, decrements, stores and somewhere. Okay, I think it only parses the argument or whatever. We go here. Okay, so it moves to EDI, maybe EDI. Where is EDI? Okay, EDX. So move EAX to EDX. EDI. Where is EDI? Okay. You know what? Hell with it. We just okay. So okay. So it will store everything in the stack, maybe. No. Okay. Let's do F4 to exit from the loop. Like doing F2 and F9 basically. Does those actions in one press. And let's see what they have in EDI right now. We have, let's do pop EDI. Okay, so it takes the last part of the stack, moves it to EDI, which is basically the iText section. It goes to, okay. So basically, it took the yeah, pass key whatever here. Okay, so move it to AX. Okay, it's moved to AX, pushed it. 0 what it is. This, try to resolve it. Pointer, I don't know. Don't try to understand everything because you'll go insane. Okay, just go with the flow. Yeah, okay. So there is an argument here of 90. This like okay, some kind of argument, and then it goes yeah, I think I'm going too much here, you know. I think what is this? 4404040. Move, exchange, there. See if there is a XOR or something like this here. XOR is this is a regular. It's a zeroize. This XOR is not like a XOR encryption. It's only zeroizing the ECX register. So we have here div and another XOR EDX. What do you have here? No, I don't recognize it. Okay, so let's go. Cannot decompile it because it's x32-bit and I'm using IDA free 64-bit. Kind of frustrating and annoying, but you know, IDA is my choice. I can use Ghidra for the compilation, but you know, whatever. Okay, so let's execute it. Takes the value of 4f. The return value is 4f. Wonder if it's the same always, or if I re-execute it, it will change. Okay, whatever. Let's continue. Again, the peb. We have the peb. What I try to do, so it's sorry x. Okay, so whatever. So ex to ebx. Now ebx holds. Okay. Okay, so this is the most of the time this memory will be recognized as the execute, like the self-executable, like basically it goes to itself. Okay, so ESI, what do you have in ESI? 80 EBX and ESI tries to calculate some offset, I think, or whatever. Oh, okay, so it got to the PE section. Now it got, okay, so now it goes to the text section. Or maybe it tries to get the, you know, get the memory offset of the text section, you know, AX, yeah, okay, and takes it as an argument. So now it takes the text section, takes it as an argument, and then does some mumbo jumbo stuff. I don't know. Whatever. Maybe it just validates whether it's text section or something else. I don't know. This is my intuition. Let's see how many times it's used. Only once. Like there is only one function declaration or usage in the code, basically. Okay, it gets me this value. The return value is this. Maybe it's the, I don't know, it's some kind of calculation of the text section or whatever. Then it compares to AAX. If it's compared, okay, I think it tries maybe to check the length of the section or whatever. Okay, so NABX or push it, okay. Okay, there is push this, that. Okay, what do we have here? So what this function will do? Okay, so okay, here we go. We have a XOR of something with something basically, and I think EDI will hold the, so basically takes number of arguments. So the XOR or decrypt. So if we go inside, we'll take this argument, which is okay. So this is the 4f. 4f is it's basically the, I think it's the XOR key, maybe. Sign EDI. So we have ESI. ESI is 0. And EDI is text. Okay, so maybe the decrypted content will go to text section. Yeah, kind of what we talk. Like text section is the encrypted, and then it will be decrypted, like unpacked. Okay. So ESI is nothing. I think. Okay, so what do we have here? 4F. You know, BBP. So var 0 dl xac. Okay, eventually. What do we have here? AL is 74, EDI is the destination, and boom, XORs it. Okay, so now it hold in the EDI. So yeah, now it's going to loop. Will be 6. So yeah, basically kind of I don't understand this 4F thing. Maybe I'm too much. Maybe it's too much. Okay. Does some calculations, adds BL. BL is basically goes into EBX. Okay. EBX. X, it's argc. Argc is the 4F. Was 4F. Okay, so I think 4F49 A2. 4F49 A2. So now it uses A2. Yeah. So yeah, basically it's a XOR. So argc holds argc holds the XOR key. Yeah, I think XOR key. Yeah. So boom. Now it goes. Decrements ESI. ESI holds the decrements ESI. And increments EDI, because EDI holds the next thing that you need to create. MCL. Okay, so okay, so now we have E4. So again, XOR key. We have here increment DL. So now it's D4. DL is D4. Zero C. I don't determine if it's part of the encryption key. Yeah, it's kind of, doing some shitty stuff. Zero C. Yeah, whatever. Whatever. So let's go do F4. Eventually, if you go to the address of EDI, you see it actually done something here. Like, yeah, done something here. So, yeah, so this is the decrypted store here. Yeah, and it will go now. I think it will do it for the next sections. Like now it will go for the iText section for whatever reason. Do some comparisons, blah, blah, blah. Yeah. So the iText, of course, is not a section that you need to decrypt, because the iText section is the current section that we're playing with in the stub, as the stub code plays here. Okay, so another call, blah, blah, blah. I think this is the okay. So yeah, goes again. Somewhere takes the password. Checks the section, checks whether it's not the iText section or this section, whatever number it is. Every section has its own like identifier here. This is like I think this is the iText section, or maybe this. So it checks both of those sections, and if it's not them, it will go and decrypt the next code section. So decrypt, and eventually it will decrypt it. So let's go F4, F7. Okay, so return from this decrypt. So we can call it basically, decrypt. It decrypts section, decryption here. So this is the code. This is what it does. Okay, it is what it is. Okay, so now it does nothing, then goes to this call. I think it didn't actually resolve it, so code analysis, reanalyze, yes. Okay, so we have something here. Yeah, I think is the decrypted version. Yeah. Okay. So let's get with it. So let's go. I have here some pushes. ESIDI. ESI is this iText start. ESI. Move to EAX. Move something to EAX. I don't know what it is. And it does XOR. What is this? What is this value? Or let me check it real quick in Google. You know what? Maybe it's something. Maybe it's a kind of XOR key. I don't know. LockBit. I don't know. Okay, so if something referred here, or okay, what it is? Okay, I think it. Oh, it's a different key. Wait a second. 6D FCA. Four five zero 6D FCA. Ah, because it's PDF. This is why I cannot search it. Oh man, hate it. Okay, so this is the XOR key. Okay, after the decryption unpacking. So this is the decryption. It's actually, yeah, it's actual decryption. It's not unpacking. Unpacking is something else, like compression, decompression. You know, if you go to my my videos, other videos in YouTube, of unpacking, manual unpacking of pin compact, UPX, and ASPAC, it's different. It's different. Here you can just put breakpoint on virtual alloc, virtual protect, or create process internal W API functions and pray that you will have an unpacked version. Something different. It's a decryption. I don't see, like, maybe it's referred to as unpacking also because there are some compression algorithms and so something with AP-lib maybe. I don't know, maybe. But whatever. Okay, when dynamic resolve function that receives the input of a string that is XORed. Okay. Okay, so now this is the resolve of the functions. Now is the build of the IAT, I think. Okay. Okay, so now it will resolve the IAT. Okay, so let's get back. Let's get back. So it moves this into EAX and then it XORs. Okay, what the hell it gives me? Nothing. Why? Okay, nothing. And then it calls this. What is this? F7? Let's do F7. Blah, 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 blah. Yeah. Okay, so it's resolved something in the text section. Okay. So, okay. So, got here. This is the point we are here. So, what is this function? Trying to like maybe let's take a memory snapshot. Maybe it can help us. Maybe it can help us. Like memory snapshot, all segments, and then we can basically we can statically analyze it, like stop the debugging and continue analyzing it. You know, if we want. Sometimes it can take some time because if you have a lot of memory code segments loaded, it can, you know, yeah, here we go. So okay, so let's go to this function. And what do we have here? Okay, I think I recognize it. I think it's like both of those hashes, like this and that. I think it's like get module handle and get proc address. I think they literally got it, like actually got it from dark side or black matter energy. What was the name? I don't remember. If you go to my YouTube channel, I have a video on dark side. It's kind of looking me like the same. Okay, so let's go with it. Like initialization, blah blah blah. Push some EBX. What is EBX? Okay, EBX holds 0. ESI holds. Okay, why? I don't know. EDI. I don't know. Okay, compares. Then it loads this to EAX and then XORs. Okay. Maybe I saw something else. I don't know. Okay, so then I have this. Yeah, I think it starts to build the IAT, the import address table. Oh shit. Okay. So push. Now I push to the second, then you have this function. Wait. You have this function. What the? Like the same. 9. It calls itself? What? Why? Weird. We'll go now and resolve something. Okay, so it goes to itself. Let's see cross-reference. We have a couple of those. Kind of weird. So who called this function again? Wait, who called this function? This guy, yeah. So it's resolve. I think it's only dynamic API resolve. This is what it is. Okay, so let's do F8, I think. Okay, so resolved as okay, so Okay, so the fact that we have now anti-DLL result here, interesting. So like goes into dynamic API resolve, compares. So I have here again goes to anti-DLL, goes to anti-DLL. Okay. So then goes to some weird instructions. Whatever. Code from, I think it's like literally code from black matter or dark side. I don't remember. So source increments, blah 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 blah. Goes to the PE section. Now I think it will do some offset ninja style offset calculations. Then again, another thing. Okay, what it tries to do. Okay, I think it's literally a code reuse. I think, like, reminds me. Okay, so go to EDI. Then there's a call here. Call to what? F7. Code. What? Okay. We can do run until return. Yeah. Because I didn't want to go through this code. I don't recognize it from the first packed code, like something standard which goes by on and on and on again and again. Validates stuff. Okay. ESI, EDI, whatever there is ESI and EDI, I always check. ESI and EDI. Okay. Tries to do. And another call to something. Again, the same function. Or the same looking function. I don't know. Again, ECX6. Again, just F8. This. It goes to some NTDL functions from NTDLL. I don't know. So, everyone compare, jump. Again, same thing. Okay. I think we can skip this and go to, like, I'll put a breakpoint here and a breakpoint here, like from like the exit jumps made, you know. Let's go F9. So it got here. Let's remove the breakpoints. Then it tries to do whatever it tries to do. Okay. It actually called something and it didn't. Okay. I see it coming. So it calls this function. Call this function. Okay. Takes argument. Okay. Okay, jump, return. So call dynamic API resolve here. Okay. So test the AX, jump, blah, 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 and tries to push some stuff. What? It's a create process? I think it's a create process, you know, because like all the arguments, maybe it's not. Only AX. Need to be careful here. If I'll do F7, it will resolve it. Man, anti-DLL what? What is this? Expected to see some, you know, functioning or whatever. Okay. Ah, it's stuck. Whenever it goes to anti-DLL, got stuck. I get to you real quick. Okay, got back to you. Got stuck for some time. You know, IDA frozen because it's hard for IDA to parse anti-DLL. Ooh. Okay. So let's continue. What do you have here? Okay. X. So eventually it will need to do some resolve, I think, wherever. And again, dynamic APIs will not go again into this function. I think. Yeah, okay, so. Like it takes both of those keys or hashes or whatever. So this is the, I think this is the hash to be resolved. This is the XOR key. Yeah. So let's continue. Okay, push to some offset, call something. And got crashed. Interesting what it got called. Okay. And it will try to go resolve. Maybe it will better to go to this specific address to do the same with xdbg, maybe. Yeah. Let me try to maybe get it back somehow. In here in this code. Give no. Set IP. Okay. Forget about it. So yeah. We'll go resolve. Yeah, this all the resolve. I think basically this is the IAT. It will go and do the magic. So I will pause here. Basically, I'll do another video. Continue. Maybe I'll continue with this. Basically, you know, this is the general idea. It will, you know, so I'm thinking about maybe doing a video continuing it, but again, it's like it's the same idea. It will go decrypt like we already saw. It decrypts a section, the text section, and then goes and resolves the APIs. And I think there it will basically go start with the ransomware thing, you know, search for backups, services, delete stuff, you know, encryption, note, yada yada, all the ransomware. So I'll think about maybe doing another video, but basically this was like a kind of a some fun with it. Okay, so basically it was very fun for me. I'm glad that you're watching my videos. Appreciating it a lot. Hope to see you basically coming back. And please do the algorithm stuff. Do subscribe, do the like button, share this video with your peers, and hope to see you soon. Thank you and take care.